All right, hey folks. We're starting a little bit after the hour. I'm Alek Sharma. Welcome, the developer advocate at CircleCI. So today's webinar is what is continuous integration and why is it important? So here's just a brief table of contents for what we're going to be covering today. If you have questions before I start here, we've got some extra help here managing the questions. So just type your questions in the comments, and then we'll get to them at the end. I think we'll have like the last 10 minutes for questions. So that way we can go through the whole thing uninterrupted. Anyway, so table of contents is one is going to be me and why I care about this, just kind of a bit about my history. Two is what actually is continuous integration. Three is why you should be doing it. Four are some real world anecdotes from where I've worked, where continuous integration could have helped. And then five is the last bit, which is challenges of becoming continuous. So here's the story thus far. This is my story thus far. First place I worked at is actually the Walt Disney Company, which is not a software company, at least in the strictest sense. And that's where I learned about bottlenecks. That's the only reason I really mention it here. Then I went to Dev Bootcamp, and this was back in 2013. And I had taken some computer science courses, but that's where I picked up Ruby on Rails. And then I headed to Blue Water for a Rails consulting shop. So we had a lot of clients who needed various features from us, but we weren't building a single app. From there, I went to Soch, and that was a Python Django shop. Much larger team, by the way. That's the big difference. Blue Water had a team of maybe 3 to 4 engineers. Soch was around 20. Postmates acquired Soch in November of 2015, I believe. And obviously much larger engineering team, but also a Python Django shop, although they were in the process of breaking a lot of their monolithic app into microservices in Go. And now I'm here at CircleCI. So the reason I say all that is because I learned a lot of lessons, I think, along the way while working at these places. And some of those lessons had to do with continuous integration and explains why I'm so passionate now, I think, about CI and why it's important. But what is it? So let's handle that question. I looked it up for you in true technical fashion. This is how we answer our questions as engineers. And this is the 8th Google result. So I'm just going to read this. This is the only time I'm actually going to read the slide directly to you. I know that's kind of a faux pas. But this is Martin Fowler, a thought leader, and he works at ThoughtWorks, or I believe he just consults for ThoughtWorks now. But this is what he has to say about it. This comes from his Blicky, which is a portmanteau of blog and wiki. Continuous integration is a software development practice where members of a team integrate their work frequently, leading to multiple integrations per day. Each integration is verified by an automated build, including test, that's crucial, to detect integration errors as quickly as possible. Okay, so pretty simple to understand. You're merging these changes into a shared source, and that source is where you're going to be running tests to make sure you're not breaking anything. But I'm going to use a metaphor here instead to kind of ram this home. And obviously it's going to be Disney since that's where I worked before. So this is from the movie Ratatouille. And there's a part in Ratatouille where this human named Linguini, who's a janitor, passes by a pot that's bubbling on the stove. And he wants to be a chef. And so he desperately sort of adds all these ingredients at once to the pot. And when he tastes it, it's awful. It's horrible. He wants nothing to do with it, and so he leaves. And then Remy the rat passes by, and he smells the soup, and it's disgusting, and he feels this urge to fix the soup. And so what he does is he adds ingredients one by one, and after each ingredient, he's actually tasting the soup to see if it's passing his own taste test. And this is the way I think about it. I think this is the best way to think about continuous integration. It's like cooking. And the reason that Remy the rat's method worked better is that he was moving in these incremental steps. But let's get back to reality. Let's not talk about Disney movies. Usually a picture with words is worth 1,000 words, but in this case, I think it's worth 10,000. This is a more visual way of representing a workflow for continuous integration. You'll have multiple developers pushing changes to source control. That could be GitHub or Bitbucket. And then you have the build server actually spinning up a build with your database and seeding that database with whatever data you need to run your tests. You'll run those tests, and then you'll be notified of whether something broke or whether something passed, and then you'll continue working as a result. I want to pause here also to distinguish between continuous delivery and continuous deployment. A lot of the times we'll say CI/CD in the same sentence. It's because they're very closely related. The difference between those is that continuous integration is just talking about merging your changes into the same source, while continuous delivery means you're actually delivering that code to a production-like environment. So when I say continuous integration, often what I mean is both of those in tandem. And that will become more clear when we talk about the benefits later. So just file that away. And if you have questions about that, we can get to it at the end. So where's CircleCI in this process? Well, we sit right in between commit and deploy. So basically, after your code has been reviewed on GitHub or Bitbucket, it'll be passed off to CircleCI or your continuous integration service of choice. Run the tests, make sure everything's passing. You'll be notified of whether it's successful or not, and then you'll move forward to wherever you're deploying, your target deploy. And that could be Heroku or AWS, something like that. And then that cycle will repeat, right? Cool, how does this happen? This is just some sample configuration. There's a lot going on in this slide. All you really need to know is that there has to be a way of controlling what you're doing in that phase between committing and deploying. And this is what we have chosen to do here at CircleCI, which is put that configuration basically as code. You're checking that into whatever repository has your application. And then we use this YAML format to specify the order of operations, where we're getting dependencies, how we're restoring or saving a cache, and then setting up the database. So this is almost infinitely configurable. And you can check out our docs to see the gritty details of this. But why? Why would you use continuous integration? Why is this something that you should be doing? And to answer that question, I want to talk about commit to deploy time. I've said that phrase now a few times, and we're just going to explore what this variable means here. And I'm going to call it CDT from now on too, as well. So commit to deploy time is the time it takes for code to get from review to a deployable state. And what even happens during CDT? Well, let's say that you take 15 minutes to build and run your automated tests. Okay, so it takes 15 minutes to actually get the build going and then set up your test database and then run those tests. So 15 minutes for that. And then it takes another 5 minutes to build again, because you need a separate build, and then deploy to staging, somewhere where you're actually going to be looking at it with human eyes. And then another 10 minutes for manual QA and spot check. And this is kind of, this is optimistic. This is a total of 30 minutes CDT. So the thing about having a high CDT, or really the reason you want CDT as low as possible, is that it leads to this vicious cycle. And this is my own theory on this. But basically what happens when you have a high CDT is that as engineers, we're trying to optimize for everything, right? We want to be able to get as much code out as possible and move as quickly as possible. And the way to do that, if we have to wait 30 minutes, for example, for a one-liner change that maybe fixes a bug, maybe a critical bug, that's not going to cut it. And if we have maybe a smaller change that isn't as crucial in the moment, we'll want to make sure that we're making the most of those 30 minutes. So this actually leads to longer pull requests. It leads to longer code reviews. And there have been studies done that have shown that we're really bad actually at maintaining context. So any code review that goes over 400 lines, we start to lose interest. We start to lose the ability to see detail in those code reviews. So this actually leads to worse code. Like, we're not even able to get the right answers from our reviewers just because they lose interest. And this is probably the main thing. I think this might be the crucial thing about the vicious cycle here is that because you have these longer code reviews, if something goes wrong as you're actually pushing that code out, you have to be able to maintain all this context on what you just changed in the code base. And if you're pushing more code, it's just like Linguini and Ratatouille. Like, you don't know what actually might have caused the problem because you were adding way too much at once. So this leads to context switching, which we know is kind of the bane of our existence as engineers, and multitasking, which again is very hard to do well. And so overall, that lowers productivity. We can't create as many features if we're running into errors more often. And then when we actually need to fix those bugs, we can't do that as quickly. So fewer features is bad for customers, it's bad for growth. Fewer bug fixes leads to churn, leads to customers losing interest in the platform or your product. And overall, this is the bottom line that results in less money. It just results in less profit. So that's the takeaway from this slide, is that a high CDT lowers your profit. So just remember that. I'll keep repeating that. This is the TLDR, probably better stated by Daft Punk. So I'm not even gonna, I won't sing the song to you, but basically it leads to more features, code quality. You'll be iterating faster. There's stability. And you'll be able to fix bugs quickly after they happen. You'll know exactly what caused the problem because you've made these small changes. Great. Okay, so this has all been theory up until now, and then also some lyrics from a song. But how does this work in practice? And so I'm going to jump now into some anecdotes from my own past about some setups that probably could have benefited from adding continuous integration to their workflow and continuous delivery. So this is company A, okay? It's anonymized for their protection. And we were in a 2-week release cycle. So that meant that we were working on features developed in relative isolation. And we kind of knew about the features that we were working on just a little bit, but we didn't understand the nitty-gritty. We didn't understand what areas of the code were being touched until the end of those 2 weeks. Another big problem is that we weren't running tests in between commits. So it would be 2 weeks worth of code and changes from a bunch of different teams. And no consistent test suite was even being run on a regular basis until the end. And so at the end of this 2-week release cycle, we would have a release lead who would create an integration branch who would bring in all the different projects that were worked on for those 2 weeks. And that was created the day of deploy. So it wasn't a lot of time to fix merge conflicts. And here's the thing about that is there were a lot of merge conflicts usually because we hadn't developed while communicating with each other. So the release lead would have to resolve these merge conflicts. And even if you resolve merge conflicts, that doesn't mean your code is actually working properly. It just means it's compiling properly. So that wasn't even a guarantee. And then on top of that, there was only one engineer who actually knew the multi-step process to deploy the application. And it was a multi-step process. There was a series of steps that had to be performed in a very certain order. And only one engineer on our team knew how to do that. So that was a bottleneck, and that's the reference to Disney that you're all waiting for. So now I'm going to get into some hard requirements of continuous integration. Why is Arnold Schwarzenegger here? This is the #1 thing I think that has to be in place for continuous integration to really even mean anything. You have to have a rigorous testing culture, and this is something we lacked at company A. You've got to have an agreement among your team that testing has to happen regularly, and you have to write tests along with your features. This is kind of a deal breaker. Continuous integration without tests just means nothing. You could have 100% green build, right? And that just doesn't really mean anything. You're not actually finding bugs if you're not catching them. And that's how you catch them, by running tests. Cool, I hope you enjoyed that slide. I worked hard on that one. #2 is automate your deploy workflow. This Rube Goldberg machine sort of thing is exactly, not exactly, but it was very similar to this multi-step process that our release lead had to go through to actually get a deploy in place. So he had to, he had to do so many things. He had to install dependencies. He had to load a schema into the database, set up the database, seed it with sample data, run the tests, and all this was happening because we didn't have a consistent way of doing this. So this needs to be a one-step process. This needs to be a one-button process rather than this whole thing. This is sort of misleading, actually, this image, because I think it is a one-step process, but I don't really know where the machine begins and ends. Let's move on. Number 3 is commit early and often. And now I'm going to go into another metaphor here and talk about relationships just briefly here. Conflicts that stay undetected for weeks can be very hard to resolve. That's what Martin Fowler says. He's also a couples therapist in his spare time. And what do I mean by this slide? If you've ever been in a relationship or a friendship or anything like that, and you have a problem, you have an issue with something the other person is doing, maybe you have a pet peeve or something they do bugs you, and you don't say anything about it, right? You just kind of let it sit and fester for weeks at a time. Well, eventually that's going to lead to some sort of explosion, some sort of fight, because you're going to have a conflict, maybe a merge conflict, right? And that's exactly what happened at company A, where we would spend weeks not knowing what the other teams were doing. Problems are much easier to detect when they're little and when they happen sooner. And so the way you get around that for continuous integration, one of the requirements is that you have to be committing all the time. You've got to commit several times a day if possible. And that way people are kept in the loop and they know what you're working on, and you can actually move forward and catch bugs before they happen. Okay, so we're going to move to a second company now. This is company B. These are creative names, I know. So company B, what is this bullet? I think that bullet might be a typo. But basically at company B, we had no way of running tests locally. And so let me just back up and describe our deploy process at company B. We had to get our code reviewed and get it approved before we got in line to deploy. And the way we deployed was through a Slack bot. We would actually jump into a Slack channel and add ourselves to the queue. And when it was your time to go, when it was your turn to actually deploy, you would go ahead and push to Jenkins. We were using Jenkins. And we would run the tests on there. But that was actually the first time that we were running our tests. Locally, we could run our test suite, but it differed from our production test suite. So there were a lot of tests that were actually skipped locally that would only run in production. And so the reason this matters is that we might find out in the queue, that our code introduced errors. But at that point, we had already kind of committed to deploying, right? So everyone behind us in queue had to wait for us to either resolve the bugs, because you were basically in the hot seat at that point. You either had to fix the bugs right there on the spot because there were other people pressuring you because they needed to get their stuff out, and it might be even more important than your work. Or you actually had to hop out of the queue, fix the bug, and then jump back into the queue, and that was more likely what happened. So huge loss in productivity. Obviously, this increased CDT, right, commit to deploy time, which slowed us down immensely. So this leads us to some more requirements, some more hard requirements, is that you need to be using clones for testing. You got to have proper environments set up for testing. You can't trust the tests that are going on locally. We all kind of know that. So your CI server should look like this. This is where you're actually running your tests, right? And it should match. It should be an exact clone of production. Otherwise, you have no guarantee, right, what you're testing is actually going to be working in the wild. This is what local dev looks like. It doesn't have to be the same, and we know it isn't. Number 5 is keep builds fast for fast resolution. Why is Mario up here? Mario is up here because in games, good games, I'd say, there are great feedback loops. Okay, so you have a certain number of lives, and maybe you fall off the edge of a level or something like that. So you die, and you're like, okay, next time I will jump in this spot. And the feedback loop needs to be fast enough that you're making progress, that you're learning from your mistakes. The feedback loop at company B was pretty slow, right? It took maybe like 30 minutes for our tests to run on Jenkins for us to figure out whether anything was actually working or not. So, and again, that was the first time we were running those tests inside the queue to actually deploy our work. So that feedback loop was so slow, it made debugging a lot slower than it even really needed to be. If we had been able to see whether our code was passing before it was reviewed, right? If we could somehow see in GitHub that all the code was ready to be merged, it passed all the tests, imagine how much time we could have saved. Cool. So now we're switching gears a little bit to if CI and CD, if continuous integration and continuous delivery are so great, why aren't more people doing them? Well, I mean, what's getting in people's way? And this is colossal iceberg, which is the other less pleasant meaning of CI. I think maybe, hopefully, people have a good understanding of CI right now. But there's a big difference between being continuous, kind of the idea of doing continuous integration, but actually doing it. And it's a much smaller feat to be able to understand continuous integration, but there's a lot more going on. There are harder tasks beneath the surface when you're actually trying to introduce continuous integration to your organization. And what are those things? Well, some of the top excuses that we hear for not being able to introduce continuous integration to the team is time. We don't have time, right? Here's a common complaint. This is real. This is a real quote. I don't have time to write tests. I need to ship features and run to my business goals. I'm late, I'm late, I'm late. So this time excuse sort of encapsulates, I don't have time to write tests. We don't have time to build this infrastructure out. And while that may be true in the short term, I think we all know that having tests catch those bugs in the long term does save us a lot of time. But how do you get that test suite in place? You can't just write a test suite up front. Just write a test for every bug you find and gradually increase your test suite. This is a great place to apply recursion, actually. You can continuously integrate the concept of continuous integration into your organization. Don't bite off more than you can chew. Just introduce it in small chunks. Excuse number 2 is probably my favorite excuse. There's a genuine fear of change in the industry, and we're all human. I mean, we understand that we don't like having to change. If we have a way that works for us, then we'll stick with that, right? Here's another real life quote. This town isn't big enough for the two of us. I fixed everything at the last minute with gobs of spaghetti code, but it works because that's how software development is. If you don't like it, leave. And so this could be maybe a hero who stays up late at night and fixes bugs on the fly. But it could also be maybe an engineer who's done something in a certain way and is just a little wary of introducing a new fangled workflow because all these ideas emerge, and some of them aren't always great. So this fear of change, this maybe prevents you from getting buy-in. If you're having trouble convincing your manager, for example, that this is worth it, one of the best ways to do that is to just use the next small project in your organization as a proof of concept. Just do it. Don't ask for permission. Beg for forgiveness a little bit later, and you'll get to where you need to be. It's much easier to make your case if you have an actual example of it working. So introduce continuous integration to this small project and show how fast you're able to move. Show how your productivity is increasing. Show how you're able to be responsive to bugs and churn out more features. And that's definitely a solid way of convincing someone. And then excuse number 3 is compliance. People get worried that basically the order of changes might get lost, right? If you're moving this fast, how do we ensure that we're actually getting sign-off and consent on all the changes that are being introduced? Well, the nice thing is that, yeah, this is the actual title of the painting too. Change manager worried that changes will happen too quickly and be lost in the madness that is continuous integration by Edvard Munch. The great thing about continuous integration is that it automatically creates a changelog for your records. You'll have that in place. It'll be saved, and you'll actually understand even more in more granular detail the different phases and where you're actually introducing changes. So you'll have a much better idea and a much better breakdown of when the code was reviewed, when it was merged into master, when the tests ran, which tests passed, which tests succeeded. So anyway, you'll get that. So accountants and auditors can rest easy. So that's kind of it. We're about at 11:30, and I just wanted to wrap up with a summary of what we learned. It was kind of conceptual. There were some real world examples. We learned what continuous integration is, why you should be doing it, how this affects the real world, and then how to overcome some of the primary challenges of starting continuous integration or introducing it to your organization. So thank you. Thanks for spending your Friday with me, or a fraction of it. You can reach me on Twitter at Alek Sharma. You tweet at me, or you can read some of my stuff, my tech fiction, on Medium or on our blog. But yeah, happy to take questions, and if there are any. I'm reading the questions right now. Do I need to use Docker to do CI? It's a great question. You don't need to. Using Docker makes CI a little bit easier. It bundles a lot of your dependencies into images that may be saved on Docker Hub. So you don't need to. We work closely with them, but you don't have to do that. Continuous integration can happen without that. It's flexible enough that you can install the dependencies on your own if you want to do that. How is CircleCI different from Jenkins? Great question. Yeah. Jenkins is open source. I think that's probably the biggest difference. And it's older. And the way Jenkins goes about this process is through a lot of plugins. So you'll have to set up numerous plugins in order to get a lot of the functionality that you might get out of the box from CircleCI or something like Travis, or those things that are, they just work out of the box. So, but the biggest difference is that usually what ends up happening with Jenkins, just because it is so customizable, that's sort of its blessing and its curse, is you'll end up with a couple of engineers on your team who end up becoming Jenkins experts. They'll end up having to manage and configure Jenkins for your project. It's probably the biggest difference. You can do continuous integration and continuous delivery on both Jenkins and CircleCI. I don't want you to get the wrong idea there. But Jenkins will require more effort on your part because it is a little bit more flexible. It will not hold your hand as much. So that's kind of the biggest thing. What you want to be doing is empowering developers. You don't want to have to basically make or assign roles within your organization to manage Jenkins. We believe that it's really about empowering developers to kind of forget about that type of thing, just not have to think about certain aspects of development. Just get back to building features. How big should a project be to be worth implementing CI? You know what? Honestly, that's a really good question. I think the smaller, actually, the better, or the more obvious the decision is to introduce CI. So it's going to be helpful no matter what size you're at. It becomes harder to introduce at larger team sizes, but it has immediate benefit for any team size. And let me make sure I'm actually understanding the question. Yeah, so I really am going to stick to that. So if you even have a personal project running on CircleCI, which you can do, we actually offer a pretty generous free containers so that you already can set up CircleCI for your personal projects. But it's going to be already immensely helpful because you will actually work faster because you'll know when your tests are failing. We have this integration with GitHub and Bitbucket where you'll know whether or not the changes that you just made are breaking the application. So you'll know instantly. So those benefits carry across team sizes. Great question. That's a really good question. Anything else? So I know we're ending a little early here, but if there are no more questions, then again, thanks for your time. Please reach out if you have anything else, or if you think of something after this is over. But yeah, once again, thanks for joining me today. I'm Alek Sharma, dev advocate at CircleCI, and hope you learned something today.